Okay, here we have another example where we're trying to do integration, and once again it involves a composite function. This time our composite function is actually our sine function. So it could help to rewrite this as integral of sine x quantity squared and then cosine x dx. Well, with lack of anything better to try, we begin by allowing u to be the inside of our composite function, sine x in this case. And we just have to hope that it's going to work if we have, if the rest of the stuff that's left over happens to be what we need. And so we find du by differentiating sine x. We say, well, that's cosine x dx. And lucky us, that's exactly what we have left over. So we can, at this point, carry the substitution through, replacing the sine with u. So we get u squared, and the cosine x dx gets replaced with du. Okay. And at this point we just have a u squared du, so we can carry that through. And so that would become add 1 to the exponent, divide by the exponent. So we have u to the third over 3 plus c, and then finally we can replace that with sine, so we get 1/3 sine cubed x plus c. And so that's our integral. Okay, so we're always looking for this, and this is what we're hoping, is that the stuff that we need happens to be what we have. If we had just tried to do this integral, this less complicated looking integral, at this point in time we are hopeless with just this point of view of substitution. Now you may recall there's actually an identity that you have that allows you to rewrite sine squared of x in terms of something else. And if you can rewrite that, then you actually can do the integral. But for now, we're kind of hopeless on that problem. Even though it looks simpler, because it is simpler with integration by substitution, it actually becomes harder. That's something you'll actually see a little later on.